right, so in this lesson we're going on to section 3.7, transformations of polynomial functions. Our first learning target in this section is going to be looking at how to categorize a polynomial as either even, odd, or neither. So if you're given a polynomial, there's two ways to determine if these are going to be even, odd, or neither. So the first method is by looking at the graph. So I have a couple graphs here. So let's explore how to determine if a function is even or odd by looking at the graph. So let's look at this one here. I have my parabola here, and I marked two symmetric points. So I have 4, 16, and negative 4, 16. Looking at that graph, I can say, well, I have positive x and y here, and then I reflected it over this axis of symmetry, over the y-axis. It became negative x, positive y. So this function is symmetric to the y-axis, and we call that function even. So symmetric to the y-axis is even. Let's look at this one. I plotted 2 points, 2, 6, and negative 2, 6. So this would be my xy, and then reflecting it over our axis of symmetry right here, the origin, I get negative x, negative y. So this is symmetric to the origin, and we call this function odd. So symmetric to the origin is odd. All right, let's turn the paper over and practice some of these. So now I'm on page 60 of the note packet here. All right, so brings us to our first learning target. I can identify even and odd functions from their graphs. So let's write down the success criteria. Symmetric to the y-axis is even, symmetric to the origin is odd, and if neither one of these are true, then you call it neither. Let's look at A. So I have the point 1, 1, and reflected over the origin here, symmetric to the origin, negative 1, negative 1. So positive xy became negative x, negative y. So this is symmetric to the origin, and we call that odd. All right, next one. Positive 1, 2, xy became negative xy over here, reflected over our axis of symmetry, which is the y-axis. So symmetric to the y-axis is even. Now let's look at C. So C looks like maybe it could be symmetric to the origin, but it's a little bit off. So let's test this out. So I have the point 1, 2. So if this is odd, then the point symmetric to it should be negative 1, negative 2. Negative 1, negative 2 is right here. That is not even on the graph. So this function is not symmetric to the origin. It's also not symmetric to the y-axis, because that point would be over here. Xy becomes negative xy, and that is also not even on the graph. Okay. So this is neither. Okay, let's move on. And you try it. Next page, page 61. Go ahead and try those two on your own. Pause the video and do that. right, so A would be symmetric to the origin, so we call this odd, and B is symmetric to the y-axis, and we call this even. So that is how you classify a polynomial as even or odd just based on the graph. So let's look at the second method of how to classify these. The second method is by their equation. So this was by their graph. Now we're going to look at just the equation of the function. So I can identify even and odd functions from their equations. So here's your success criteria here. So step one is always to replace x with negative x and simplify it down as much as you can. And then after you put in that negative x, if you get the same function that you started with, then that's called even. And then if you put in the negative x and you get the opposite function, then that's odd. And to figure that out, you would have to factor out a -1 to see if that became the opposite function there. Or if neither of these are true, you say it is neither. So let's practice this. So let's look at A. So step one is to replace every x with negative x. So everywhere I see an x, I'm going to replace it with a negative x. Now when you're simplifying these, you need to use this rule over here. You're going to look at the exponent of this negative x term. If it's even, the x becomes positive. If the exponent is odd, then this whole term becomes negative. So negative x to the fourth. 4 is an even exponent. So this becomes positive 4x to the fourth. So positive 4x to the fourth plus 5. Now I'm going to compare my new equation to the original equation. If they're the same, then it's even. So let's look. Yes, they are the same. Same as original. So this is even. All right, let's try the next one. So I'm going to take any x I see and replace it with negative x. And now I'm going to simplify. So this is an odd exponent, so that means this is going to stay negative. So this is going to be negative 2x to the third. Again, odd exponent, you could say that's a 1. So 3 times negative x is negative 3x. So it stays negative there. Now I'm going to compare it. Is this the same as this? No, it is not. So it's not even. So if it's not even, then I need to test for odd by factoring out a -1. So at this point, since it's not even, I'm going to factor out -1. So take out a negative, so that makes this positive and this positive. Now, is this the negative of this? So are these the same except for that negative in front? Yes. So that means that this is odd. G of negative x equals negative g of x. So, odd. All right, pause the video and you try the next couple on your own. All right, let's go through these. So the first one, I'm going to start by replacing x with negative x. Okay, then I'm going to simplify odd exponent so it becomes negative, even exponent so this becomes positive, plus 4. And remember, this became positive, but a positive times a negative is still a negative here. All right, is this the same as this? Are these the same equation? No. So that means it's not even. So if it's not even, I need to test for odd by taking out a -1. So factor out a negative, so you change all these signs. Now, is this the same as this? No. So then we conclude that this is neither. All right, let's look at B. So first you're going to replace x with -x. Even exponent, so this becomes positive. Check, is this the same as this? Yes, so that is even. All right, that's the end of the video. You're ready to do your practice.